Hello and welcome to another episode to learn how to code for absolute beginners. Today we're going to learn about classes. Classes are extremely important for object-oriented programming, which probably you already heard about it before, and objects are at the core of it. Think about an object as a way to represent anything that you have in the real world into your programming language. Think about any common object of daily life, for example, a microwave. A microwave is an object of itself and it has an interface to communicate with the external world. For example, you have a control to control the power, another one to control the time, and you don't have to tell anything else besides that because internally the microwave knows how to operate itself. It knows at what speed it has to move the plate. It knows how to actually radiate the microwaves into the food and all that stuff. You don't have to worry about it. You only have to worry about the interface that you have in there to communicate to the microwave. So this microwave internally has functions like the ones that we learned before in the previous lesson. So these functions operate internally, and there are some functions which are from the outside, which are the ones that we connect directly through the buttons. Think about that as a way of calling a function into that machine. That's the kind of way of connection that you have to make between the world of programming and the real world. Let's get our hands dirty and start coding, but before, let's read the definition of object-oriented programming in the Wikipedia. Object-oriented programming is a programming paradigm based on the concept of objects, which can contain data and code, data in the form of fields, often known as attributes or properties, and code in the form of procedures, often known as methods. When we finish the lesson, we will understand what actually this mambo-jumbo means. Let's create our microwave object. In order to do this, first we need a class for the microwave. The class, remember, is the blueprint. It's going to tell Python how to create this object. A common way of referring to this process of creation is called instantiate an object. It's a common terminology. First, we need to give this class a name. So it's going to be, the keyword is going to be class, then the name of the class, microwave, column. And here is going to be a block of code. So as you can see, we have an indentation. In this block of code, right now, let's write, for example, what a microwave will need. So, for example, a serial number, a brand. It will need power to know what power we want to set the microwave. It will need time, how long we want the microwave to function, operate at that power. And then it will have some actions, for example, start, and then a stop function. So as you can see, in a class, you have two kinds of things. One is pure data, like the first four things, like serial number, which is just information that we have to give to this class in order to create this object. And then there are methods, which are actually functions. And these are actions that are going to be performed when we call them. In this case, it's the start and the stop button. So how we create these actually into the code? In order to do that, we have a special function, which is called init. This function is to initialize the object. And as you can see, it has this double underscore. These functions are special, as are internal, and Python is going to use them for different functionalities internal in the code, which you can take advantage of. You can read the documentation about this. We are going to explore a little bit more of them in the future, but for the time being, remember this one. This is to initialize the object. In order for init to work, we need to set also the keyword self. Well, for the time being, just ignore this self for now and think about it as a reference to the object itself. I know this is going to be a little bit complicated to wrap your head around right now, but an object, when it is created, it occupies a certain place in memory. It exists. The class doesn't. The class basically is a blueprint, right? So, but the object itself is something that is real and exists in memory, and you can actually use it. Well, when you create this object, there must be a way for this object to reference to itself, to know where in memory that object itself exists in order to be able to call functionalities, methods internally. That's where the self keyword comes from. But we don't have to worry about that right now. Just think about it as part of a template that we have to use in order to initialize this object. So in this function, we want to pass the data for this microwave to initialize it. The first two things would be the serial number and the brand, meaning that when we initialize this object, it's mandatory that we pass these two elements, these two, the serial number and the brand. As a function, it has a column, and also you have an indentation, as you can see, which is the same we have been doing before, only that here we have one more level of indentation because the function itself is already inside the class. So the code that you're going to write for this function is going to be inside the function. So that's why you need to have these levels of indentation. It's important you keep an eye on that. So here is where we are going to use that self magic keyword. So we'll say self serial number, which is the name of the variable that we are going to create for this object. Serial number is going to be equal to serial number. And self brand is going to be equal to brand. And this might look a little bit confusing. You say, okay, why do we have a serial number here and a serial number here? Aren't they the same, maybe? Well, they are not. The reason is because one thing is serial number and another thing is self.serial number. They are two completely different things. The reason is because here when you call the function, you pass in the serial number variable. Basically, you pass the value when you initialize the object. And this is referenced without the self in front of it. In fact, we can actually change this serial number and just write XXX as the name of the parameter. And as long as we are consistent and put that here, it's going to work equally fine. But as a way to make it easier for people to understand how we want to initialize our object, then it makes sense that we call the parameters with the same name that we are going to define them inside the class, inside the object. So for now, let's stop here and initialize this object with what data we have right now. So first we need to create a variable. For example, my wave is going to be the container, the variable containing this object is equal to microwave. And here, when we put the parentheses, we basically initialize the object. As you can see, we call the object, we call the class as if it was a function, because actually internally is going to call this init function. So this is going to return a fully formed microwave object. If we run this, we're going to get an error. And the reason is because you can see that two parameters here are required, serial number and brand. The self parameter, you don't have to worry about it. Internally, Python is going to deal with it. So that's why I said before, just don't pay too much attention to that at the moment. We're going to learn more the innards of that later. But for the time being, think about this as a placeholder that you have to put in there. And here, there are the parameters that you pass. Well, we are missing two required parameters when we instantiate this object. To fix that, just let's put something, for example, for the serial number, it's going to be 123X. And for the brand, let's say that is a Ferrari microwave. It's going to be very, very fast at heating up things. So now that we do this, when we run, it's fine. It runs completely fine. And my wave became a fully formed microwave object. If I want to query the data inside the object, we use the dot notation. So for example, print, tell me what my wave brand is. So because we pass a string, because it's in double quote, and that string here in the Ferrari ended up in brand ended up in here, and here was assigned to self brand, which means that it's a parameter, it's a property of that object when it's created. So that self brand is going to contain what we pass here, Ferrari. So in order to access it, we have to type the name of the object, the variable basically containing this object, and use which is called the dot notation. So my wave dot brand. If we run this, we get returned the value of that particular property of that object, in this case Ferrari. If we do the same with serial number, we have print, and then we have my wave dot serial number. If we run this, then we get also the serial number. That's basically what you do in order to access the data of that object. We can also update that data. For example, let's say that I want to update the serial number of this microwave. So if I type my wave serial number and then equal to, we initialized it 123X, let's say like 555L. It's going to be a string as well. And then we run this, we see that it has been modified. So when we query the serial number, it's the new value that we just assigned to it. What about the power and the time? These are another two properties that we don't have yet. So initially this class, the power should be 0 because it's turned off when we instantiate it, and the timer should be also 0. So when we run this, those two parameters are already going to be existing inside, and they're already going to have their 0 value. Now let's talk about the actions of this microwave. One of them is to start it, and the other one is to stop it. The start function is just going to print on the screen start because we are actually not really building any real microwave. So we are just going to print that the microwave started. We also want to inform the user about the power that has been set, and time. For the stop, we just have another print that just says stop it. So as before, let's instantiate the object, and to execute the start function, we just need to call the object and pass the dot notation start and no parameters in it. It's just a function. So when we run this, we have started at power, self power, and timer, self timer. Yeah, I forgot the F of the F string here. So if we run this again, we have power 0 and timer 0. So now let's say that we want to pass this microwave some power and say, okay, I want my wave, which is a microwave, that power to be equal to, for example, from 1 to 10, I want it to be 6. And my wave timer to be, for example, 10 seconds. Well, if we do this and we just print again and we initiate the microwave here, start, and we run this, we will have that initially is power 0 and timer 0, and then it tells us, okay, started at power 6 and timer 10 seconds. Then if we do the same as my wave stop, and we call the stop and we run all this process again, we'll see at the end stopped. So of course, here inside these two functions, if it was a real microwave, let's say that you have a microwave controlled by some Python code and you control this remotely from your phone, from somewhere, well, in that case, these functions will have to actually perform whatever operation is necessary to make that oven to actually work. So what we're doing here is just to make an example so you can see what happens about calling an action for an object and setting data inside that object. If we want to make this a little bit more interesting, I'm going to introduce something here that we didn't touch before, but it's going to be nice to have an idea of what is coming. So we can import a library, basically a module, which is called time. So when we use this notation here, import is going to take a module. In this case, it's called time, which has a lot of functions already related to time. And we can just get that, put it here, and it means that all that code that somebody else wrote is immediately available for us to use in our program, which is great. So time has a function which is called sleep, and it allows the program to just stop for a little while based on seconds that we pass as a parameter. That will give us a little bit of more of an idea, like a feeling of that microwave actually working. So in this sleep, we are going to pass the parameter of timer. And basically what is going to happen here is that when we instantiate the microwave, we pass the serial number and the brand as before. But as a real microwave, if we don't set up the power and we don't set up the timer and we just press the start button, usually it's not going to do anything. In this case, it's the same. It's not going to wait for any time unless we just set that parameter, at least the timer, we set it. So let's set the timer and the power. The power is actually not really that necessary in this case, but let's just do it to make it more real. And then my wave timer is going to be, for example, 3 seconds, right? So now if I run my wave and start, the function start, and when we run this, we have 1, 2, 3, and it should stop, yeah. So it's waiting actually 3 seconds. If I increase the number of these 3 to 10, for example, when it's going to take longer, as you can see, there is no prompt here, meaning that it's actually waiting in that sleep function until the 10 seconds are passed. And now should be the time. Yeah, here it is. We have the prompt stopped. So this gives you a little bit of a more like a realistic sense of the microwave working. So let's take a quick look at the whiteboard so we can just summarize what we learned so far in this lesson. So as we learned before, we have a class keyword, then we have the name of the class, then we have column, and then inside here we have an indentation, and all the code of that class. That code will be def for functions, as we learned in the previous lesson. And then we have this special init function with these two underscores, which is a special function, internal special function. And here we have self, and then the parameters that we want to pass to initialize this object, the column. And here we have another indentation because this is a function. And here we have the basically initialization block of that function to create this object. So as we were talking before, this self is something that actually makes a reference to the object into the memory. You don't have to worry about this right now, but the only thing that you have to worry about the self is that you need it in order to actually instantiate the variables inside the properties inside the object. So for example, we have self dot, and we want to create one called power equal, and here we put the name of the variable that we are passing here, the parameter actually, not the variable, the parameter. So for example, this is called power, then here will be power. And as I said before, doesn't matter if it's not the same. The important thing is that these and these are consistent. These two are the same because those are the ones which are going to be read. This one is going to be internal for the object. So when we instantiate, we create the object into memory, we know how to access that data from there. So based on that definition that we had before in the Wikipedia, object-oriented programming is a programming paradigm based on the concept of objects. Now we understand where an object is. It's basically the creation into memory, the instantiation of that class blueprint into something real that we can use, which can contain data and code. Yeah, because when we had before the class and then the name of the object, here basically we create blocks of data. It can contain just data and then blocks of, with def, basically blocks of functionalities, which are the functions that we define. So data and actions. So the code and data and code, data in the form of fields, often known as attributes or properties. And that's how the definition actually goes. These are the properties, like the power or the serial number or the brand in the microwave. Those are called properties. And then in the definition it says, and code in the form of procedures, often known as methods. And these are the methods. So don't get confused about functions and methods because they are basically the same thing. There are slightly differences when we go more deep into a definition of these concepts, but for the time being, they are basically the same. What you do is just define a method or each of an action, like a verb of doing something for that object, and then the properties are the data. And you can just basically make this into anything in this real world. If you have a dog, for example, you want to transform that dog into a class in Python, that dog will have a name, that dog will have an action like barking, that dog will have another action like going to sleep or walking or annoying you, whenever. So the thing is that all this information is going to be encapsulated into that class, which is a blueprint, and then you can create as many objects as you want. Now you know the most important part of object-oriented programming, which are classes and objects. There is more to it that we will learn in the future, but for now, this is going to help us to understand how to use modules and other parts of Python. This basic course is close to an end, so the next lessons we're going to see a few more data types, and then we are going to wrap all this up together into one program that is going to cover everything we learn, and we're going to have fun with it. Stay tuned, subscribe, and thank you for watching.